means per annum means per year. Okay, per year, what happened? So exponential growth and decay can be modeled by a equals to k times a to the power of t. Okay, this is the equation. Okay, this is the equation. What is exponential growth? Exponential growth equals to k times a to the power of t, where a and k are constant. Okay, k and a are constant, where a is the amount and k is the initial amount and t is the time. Okay, t is the time. Okay, let's say we have population. We are looking for the population in this town, and the initial population we have is say 100 people in this town. Okay, initially we have 100 people in this town. So I will say the population P equals to 100 times 3 to the power of t. Okay, this 3 can be any other numbers, can be 2 to the power of t according to the question. Okay, according to the question. We'll investigate that more later. So if it's an exponential growth, the graph will look like. The graph will look like that. Okay, that's the p-value, that's the t-value, and that's the initial value 0, 100. You won't have the left-hand side of the graph because you won't have time less than 0. Okay, you won't have time less than 0. You only start from the point 0 and to the right, you have graph like that. Okay, you have graph like that. Okay, where a is the amount. Okay, a is the amount and k is the initial. Okay, but there will be some case for a. If a is greater than 0, then it is exponential growth. But if a is in between 0 to 1, then that will be exponential decay. Okay, will be exponential decay. So what's exponential decay? So it's decreasing graph. Let's say we are talking about the population of monkeys. Okay, that's the population of the monkeys. But there's some disease happened. Okay, in this town, and the monkeys like dying. Okay, the number reduced. So if it's a reduced population, what I can say is the population equals to, initially we have 1,000 monkeys, say, and then I have a half to the power of t. Okay, this a half indicates there's a decay of the initial number. Okay, it's a decay. If that base is in between 0 to 1, means there's a decay. If that base is greater than 0, which means there's an exponential growth. So if you want to sketch the decay graph, okay, the graph will look like that. Then the 0, 1,000. Okay, you start from 0, 1,000 and going down. Okay, the population is going down. Okay, the population is going down. And the base will never smaller than 0. Okay, you won't have that. That's not correct. You won't have negative base. You will always have positive base. But when the base is greater than 1, you will have exponential growth graph. If the base is in between 0 and 1, you will have exponential decay graph. Okay, so that's the case of the graph. Again, for a growth rate, okay, for a growth rate of R% per is per year, okay, per annum. So R% per year, the base A is calculated using 1 plus that rate. Okay, 1 plus that rate. Let's say a simple example is if I have $100 this year and the exponential growth is 10% per year. Okay, 10% per year. If this money can grow by 10% per year, then the base will be 1 plus 10%. That will be 1.1. Because next year, what do you have? The next year, you will have 1.1 times 100. Okay, so the base is 1 plus the growing rate. Okay, 1 plus the growing rate. That's the A value. That's how you work out A values. So if you have a 3 here, okay, if you have a base 3 here, what's the 3? This 3 is 1 plus 2. Okay, if I can put 2 in the percentage rate, that's 1 plus 200%. So the growing rate is actually 200% in this case. Okay, double, 200%. Okay, increase rate is 200%. Okay, so for the decay, if there's a decay rate of R%, let's say the population is decreasing by 30% per year, okay, decreasing by 30% per year, then the A value is calculated as 1 minus the rate. Okay, the base will be 1 minus the rate. Okay, so first, what's the K represent? The K represent the initial value. Second, what's the A represent? The base A is 1 plus the growing rate or 1 subtract the growing rate. Okay, so the base is calculated by the same way. If it's exponential growth, it will be 1 plus. If it's exponential decay, that will be 1 minus. So the basic exponential formula can be summarized as, summarized as A0. A0 will be the K value. Okay, A0 will be the K value we talked about before. And 1 plus or minus the growing rate, that will be the base A value. And the power N here, that will be the same as if you have time t here. It's a variable. Okay, you can use n, you can use t, you can use any letter you want. Okay, so that's A equals to k times a to the power of t. So the subscript 0 is often used to indicate the initial values, such as P0 is the initial population. Okay, so how to write P0? P is here and you have 0 here. P0 means the initial population. Okay, so T0 means the initial time. Okay, T0 means the initial time. Like anything 0 means the initial amount of that variable. Okay, the initial amount of that variable. So that is exponential growth and exponential decay. Okay, let's have a look. Example 1. From Exponential Rules, for the following situation, John has a painting that is valued at $100,000 and which is expect increase in value by 14% per annum. Okay, by 14% per annum. Okay, I want to form exponential rules. Let's say the value, let the value of this painting be to be $8. Okay, be $8. So A will equals to, okay, A will equals to, the initial value is 100,000. That's the initial value. Times 1 plus the growth rate, because it's increasing in values. So 1 plus 14% to the power of t. Okay, depends on the year. Okay, this is an AT graph. So you can simplify that as, that's 100,000 times 1.14 to the power of t. 1.14 to the power of t. A city's initial population of 50,000 is decreasing by 12% per year. Okay, by 12% per year. So 50000. Let's say the population just use P. P equals to that value times decrease by 12% per year. It's a decreasing value. So it's 1 minus 12% to the power of t. So P equals to 50,000 times 0.88 to the power of t. Okay. 12% is 0.12. 1 minus 0.12 will be 0.88. So that's 50,000 times 0.88 to the power of t. Example 2. Okay, example 2. House price are rising at 9% per year. Okay, house price are rising at 9% per year. And Joe's flat is currently at 600,000. Okay, 600,000. Determine a rule for the value of Zoe's flat V in n years time. Okay, the variable is already given to you. It's V dollars and n years. Okay, V dollars and n years. So the V equals to 600,000 times 1 plus 9%. That's the base to the power of n. You must use V and n. If you use different variables, that will be losing 1 mark. Okay, that will lose 1 mark. So V will equals to 600,000 times 1.09 to the power of n. What will be the value of the flat next year? Okay, what will be the value of the flat next year? Next year is after 1 year. Okay, next year is after 1 year. So when n equals to 1, V equals to 600,000 times 1.09. Okay, so 600,000 times 1.09 equals to 654,000. Okay, that's after 1 year. Okay, that's after 1 year. And in 3 years time, if it's in 3 years time, it's when n equals to 3. So V equals to that times 1.09 to the power of 3. Okay, 1.09 to the power of 3. So, okay, I can just go up to highlight this part and press enter to copy this down and edit it. So to the power of 3, you don't need to type everything again. Okay, you don't need to type everything again. So you press, you have that 777017.4. Okay, that's in 3 years time. Okay, the next one will be a little bit tedious to do. Okay, it's not a hard question, but it's quite tedious to do. So because it's asking you to use trial and error. Okay, use trial and error to find when her flat will be valued and at 900,000, round to 1 decimal places. So this is when V equals to 900,000. Okay, I want to solve that equals to 900,000. Okay, but I can't use calculator to directly solve for it. Okay, if I can use calculator to directly solve for it, what I can do is go menu, number 3, algebra. Okay, go number 1, solve. Okay, solve for something. So solve for what? Solve for 600,000. Okay, 600,000 times 1.09 to the power of n. Okay, where's n? N is here, and that go down. That equals to 900,000. Missing 10. Okay. Okay, I type this equation in, and I need to tell this calculator which is the variable I want to solve. So I need to press comma. Okay, tell the calculator which one I want to solve. Comma, and put the variable in. The variable is n. So it's comma n. Press enter. I will have 4.704 something. So to 1 decimal places that will be 4.7. Okay, to 1 decimal places that will be 4.7. But I don't know what is it. Okay, I don't know what is it. I need to do trial and error. I need to keep trying different values until you have about 9,000. Okay, until about 9,000. So let's say like I'm guessing. Okay, I give you about like this number will be in between 4 to 5. Okay, let's guess a number. Let's say the first number I guess is 4.3. Okay, let's say the first number I get is 4.3. So when t equals to 4.3, v will equals to, okay, 4.3, right? Let's copy this down and go 4.3. Going up. Okay, copy this and 4.3, enter. So I have a number less than 900,000. Okay, I have a number less than 900,000. That's 869. So I need to keep increasing this value. Okay, I need to keep increasing this value. So let's say we have 4.6. Let's say we have 4.6. And to have 4.6, I have this value. Okay, 4.6, I have this value. And this value is less than that as well. Okay, less than that as well. And then let's keep increasing by 1 decimal. Because it's to 1 decimal places. So let's go for 4.7. Okay, still not yet to 900. So let's keep increase for another decimal place. 4.8. And you can see that's go over than that. Okay, that's go over than that. So because it's 1 decimal places, 4.7 and 4.8 are 2 adjacent values. Okay, 4.7, 4.8 are 2 adjacent values. And then 1 is over 900 and 1 is less than 900. Which means the true answer will lie in between 4.7 and 4.8. And I want 1 decimal place. I need to choose one of those answers, either 4.7 or 4.8. Okay, the answer will be chosen by using those 2 equations. You need to have first 2 adjacent numbers to give you the value 1 above the value I need and 1 below the value I need. Okay, so the true solution will be in between 4.7 and 4.8, but I don't really care. I just need 1 decimal place. So which 1 decimal place will be make sense? Okay, can you see? You will use this one to subtract. You use this number to subtract 900,000. That gives me this value. And you use this to subtract 900,000. That gives me this value. Okay, this number is 386 away from the true value. But the bottom one is 7,000 above 7,400 away from the true value. So which one gives you a better estimation? 4.7 will give you a better estimation because it's more closer to the true value. So by approximation, I will have, I will try, okay, the first one I try is T4 point that, and I try 4.6, and I try 4.7, and I try 4.8. And those two are the adjacent one and give you one above, one below, and finally I choose 4.7. Okay, that's a trial and error step. Okay, that's a trial and error step. Okay, next one. Decide if the following represent exponential growth or exponential decay. So A equals to 200 times 1.78t. This must be growth. Okay, that must be growth because the base is 1.78 greater than 1. And I will have a 78% of the growth per annum or per year. Okay, because 1 plus 0.78 gives you 1.78. So 78% will be the growth rate. And this one will be decay because it's less than 1. And I'll get a 15% of the decay rate. Okay, decreasing by 15%. Because 1 subtract 0.15 gives you 0.85. So it's 15% of the decay rate. And that one will be growth. Because 1 plus that, so growth rate is 3%. Okay, the growth rate is 3%. Okay, example 4. Define variables and form exponential rules for the following situation. A human cell of area 0.01 centimeter squared. Double its area every minute. Double its area every minute. Okay, first, this is the initial. Okay, that's the initial value. Because I have 0.01 centimeter squared, that's the initial value. And then double its area every minute. So what's the growth rate? Absolutely it's increasing, right? Absolutely it's increasing. But double the area. What's double? What's the rate for double? So how many percent it grows every minute? $100 to 100. You'll be 100 because 1 plus 100 will give you 2. Okay, I will growth 100%. I will growth totally by myself. Okay, so growth rate equals to 100%. So say the area will equals to let's try here. The area will equals to 0.01 times 1 plus the growth rate, then to the power of t. Okay, then to the power of t. So A is actually equals to 0.01 times 2 to the power of t. So it's 2. Okay, the base is 2, but the growth rate is 1%, 100%. Okay, 100% is the growth rate. Okay. I'll do the last exercise first. I'll do the last one first. Okay, half-life. Half-life What is half-life? Make sure you understand this, okay? Make sure you understand this. What is half-life? Half-life is the period of time it takes for an object to decay by half. Okay, does that make sense? Half-life is a period of time, okay? 3 years, 2 years, or 5 days is the time taken for the object reduced to half. Okay, for example, I have 1,000 population, okay, 1,000 people in this town, and something happened and the population is decay, and then I want to know at which point of the time the population will reach 500. Okay, I have 1,000 at the beginning. I want to know after how many years this population is reduced to 500, and this is the half-life. Okay, originally I have 1,000, and then I will reduce to 500. I want to know after how long this is reduced to 500. That's half-life. And let's have a look. Example 6. The half-life of a substance is 100 years. Okay, I already tell you the half-life for this thing is 100 years. So which means, for example, I have 100 grams. After 100 years, that will become 50 grams. If I have 1,000 people, after 100 years, I will have 500. Okay, so half-life, this 100 years tells you the original amount will reduce to half after 100 years. And then find the rate of decay per annum. Let's say the rate is R. Okay, let's say the rate is R per annum. I don't know what is the rate. Express a percentage correct to 1 decimal places. Okay, after you read this question, you will feel like it doesn't tell me anything. Okay, it doesn't tell me anything. It's just 100 is the only number I can see in this question. And it asked me to use 100 to find the rate. Okay, it seems quite impossible. But let's write equation first. Okay, for this exponential decay. Because this is exponential decay, I will have, let's say we have this amount is A. This A will equals to A0. What is A0? Is the initial amount. Times 1 minus R% to the power of T. T is time. Okay, T is time. That's what I can write, okay? That A0 is the initial. Yeah. A0 is the amount, okay? A0 is the amount, initial amount. Okay, let's set up an equation, okay? Let's set up an equation. So, 100 years is the half-life. Okay, 100 years is the half-life. So when T equals to 100, your A value will become a half of A0. Okay, half of the original amount, right? Your A will become half of the original amount, which is A0, half of A0. So let's put those two values into this equation. A half A0 will equals to A0 times 1 minus R% to the power of 100. Okay, when T equals to 0, A will equals to half of the original amount. And that's a half equals to 1 minus R% to the power of 100. A0 and A0 can be divided from both sides and just become 1. What I need to solve is a half equals to 1 minus R% equal to the power of 100. Okay, let's solve. Menu number 3, number 1. Okay. 1 over 2 equals to bracket 1 minus r over 100 to the power of 100. Okay, I want to solve for this equation. A half equals to 1 minus r percent to the power of 100. I want to solve, comma, r. Okay, I want to solve for r. I want to solve for this r. Press enter. Okay, after you press enter, you have solution like that. But don't worry, just press Control and enter again to find the decimal places. That's the exact value. You press Control and enter, you have decimal places. And you won't have 199 because it's a decreasing rate. Okay, it's a decreasing rate. You won't decrease by 200% of itself. Okay, so the rate that must be that value. Okay, that value 0.69. Okay, 0.69. You won't take this one. It's not reasonable to take that one. You won't decrease by 200%. If you decrease by 200%, means you left with nothing. Okay, you left with nothing. So r equals to 0.7 because you want 1 decimal place. Okay, you want 1 decimal place. So r is about 0.7. So decay rate equals to 0.7%. Okay, so the question is, do you think the half-life will influence by the initial value? Do you think I have, like, say for the same substance, I have 100 gram or I have 1,000 gram. Do you think that will influence the half-life? No. Okay, half-life is only purely depends on what is the substance. Okay, whether it's it will normally talking about like radioactivity stuff. So you will learn that in physics. But the initial amount is not influences half-life. Okay, the half-life is just the time taken for the substance to reduce by half of the original thing. Okay, if I originally have 10, then it will reduce to 5. If I originally have 1,000, then reduce to 500. That doesn't change the half-life. Okay, for the same substance, the half-life will always be the same. Doesn't influence by the initial values. Okay, doesn't influence by the initial values. And also you can see from this question, I don't even really care about how much I have at the beginning. I don't even care about what is the A0 because A0 will get cancelled finally. Okay, A0 will gone just finally. Okay. I want you to do example 5. Okay, I want you to do example 5 by yourself. That's the last thing you need to complete for this thing, except the last 4 pages I give you yesterday, plus this question. Okay, plus this question. That's what you all need to do. I'm not going to collect your booklet now. Okay, just I'll wait you to finish that one and get it on Monday maybe. If I have class on Monday.